Looking into the Touch a Falling Star investigation, we're going to look further into meteorites. What we're going to do is we're going to look at some of the properties of meteorites and how we could identify a particular rock as a meteorite. Now, here are some of the materials. A small rock that will fit in your hand, not a boulder, magnet, magnifying glass, street plate, which is an unglazed side of a tile, electronic balance, and a graduated cylinder. And so check its appearance. It might be a meteorite if it has an irregular shape. The round spheres as rocks, not going to be a meteorite. Sometimes there's smooth surfaces with thumbprints. If you've got those little indentations as on the picture here, could be a meteorite. If it has a fusion crust, if you look in the bottom of the left-hand diagram, you can see some of the outer layer chipped off, and you can see a very thin layer, which is the fusion crust, formed as it gets very hot, entering the Earth's atmosphere. But not all dark rocks will be meteorites. And then do a street test. You're just pressing the rock and drawing it across an unglazed porcelain fragment. It can be the underside of a glazed tile. And some rocks give different colour streaks to the actual colour of the rock, and it says that meteorites don't leave streaks. But actually, ones that have been on Earth for a while and may have oxidized and formed a little bit of hematite will give pale brown one, but freshly fallen meteorites will give a little one. Is your rock magnetic? Most of the meteorites have a small amount of magnetic material and will be attracted to a magnet, or rather the magnet, if it's strong enough, will just hold onto the rock. If the rock is not magnetic, it's highly likely it's not going to be a meteorite. But some Earth rocks are magnetic, and very, very few, the achondrite, stony meteorites aren't going to be magnetic, but they're a very small proportion of any meteorite that you would find. And also you can check its density, because a rock has a higher density than average Earth rocks. So it's not just, is my rock more massive? It's, what is the density, the mass per unit volume? And to do that, you need to mass the rock, and you need to find its density, here showed in a graduating measuring cup. But you can use a graduated cylinder, provided it fits in. Remember not to let your rock plummet down to the bottom of a glass graduated cylinder. Just tip it on its at an angle so that it slides down. And so here in the table you can see that iron meteorites are twice the density of Earth rocks, stony iron meteorites 1.5 times, and even stony meteorites have a higher density than most Earth rocks. And there's a couple of teacher demonstrations testing for nickel, a little more complex here, and a link to go and see the method on this one from CERN in Switzerland, and a list of the materials that you will need, because the metal in meteorites is going to be iron with a little bit of nickel. And teacher demonstration number 2, using a Bunsen burner, actually heating it. Does it really get strong enough? But you need a blue Bunsen flame and hold behind a safety screen, hold the rock in tongs above the inner blue triangle of the Bunsen flame, and have a brick to set the hot rock on. And so you can now look at each of those, the results of each of the tests. Is yours an Earth rock or one that came from space, a meteorite? And describe why for each of your tests and any other test your teacher approves, why you think your rock originated from Earth or from space.